Hello everyone. So today we're going to be working on a motion problem. So right here we have an object at 40 degrees angle and it's being thrown downwards with an initial velocity of 25 meters per second. And we're also given that the total projectile time is 3.75 seconds. The problem is requesting us to find the height of the cliff, the distance from the foot of the cliff, so when it lands on the ground, how far is it away from the foot of the cliff, and the velocity of the projectile before it hits the ground. So starting with this problem, you could see that the initial vector for velocity is already at an angle, so we have to distribute it into both its x and y components. Due to this fact that motion is independent of one another, we should state what axes we are in. So the best bet for this problem will be to set our positive x in this direction and the positive y in that direction. Now, we should separate the initial vector of velocity into its x and y components. So using trigonometry, I could isolate this triangle to calculate both the Vx and the Vy component. So trigonometry for sine states that it will be opposite over hypotenuse. So therefore, Vx can be calculated with 25 multiplied by sine of 40 degrees. Additionally, cosine is stating that it's the angle with respect to the adjacent side and the hypotenuse. So velocity will be, in the y direction, will be 25 cosine 40. If you calculate this out, the x component will be 16.1 meters per second, and the y component will be 19.1 meters per second. Fantastic. Now, with both the initial velocity in the y and x direction, we could do the first two calculations for the height of the cliff and where the projectile lands with relation to the foot of the cliff. To answer part A, we could use a kinematic equation. This will be the displacement is equal to the initial direction in the y multiplied by total projectile time plus 1/2 acceleration in the y direction and total projectile time squared. Using this equation, we have all the variables already because we have the initial velocity in the y direction, we have the total projectile time, and the acceleration in this case will be the acceleration due to gravity, which is downwards at 9.8 meters per second. Therefore, if we plug in all our values, we'll get 19.1 multiplied by 3.75 plus 1/2 positive 9.8 and 3.75 squared. Now, traditionally speaking, we believe that gravity or acceleration due to gravity will be 9.8 meters per second squared, and it will be negative. But if you look at our coordinate system, we stated that it's downwards, and since we stated that gravity is also accelerating downwards, our projectile should actually be positive. So don't think that due to gravity, your acceleration will always be negative. It's completely dependent on only the coordinate system that you stated. And if you plug in this into your calculator, you'll get your answer as 141 meters. Now you see that I did this calculation in the y direction, so our answer will also be in the y direction. So this answer is part A, which is the height of the cliff. If you do part B, we could do the delta x component. For this will tell us where is our projectile going to land in relation to the foot of the cliff. And we could use the same equation. However, in this case, we have to think about what is the acceleration in the x direction. And that will have us believe of what are the forces that are acting on the projectile. Since this is a free falling object, the only force that's acting upon this object is gravity. And gravity only works downwards. Therefore, the acceleration due to gravity a will be equal to 0. Therefore, this entire variable will be null, and our delta x will just be highly reliant on the velocity in the x direction and the total projectile time. Therefore, it will be 16.1 meters per second multiplied by 3.75. And our total answer will now be just 60.4 meters. For our final case, we had to find the velocity of the projectile before it hits the ground. Since we already established that the acceleration in the x direction is 0, the final velocity in the x direction must also be the same as its initial. So we could write that velocity in the x direction for the final will be equal to 16.1 meters per second. Now, to calculate for the final velocity in the y direction, we have to use another kinematic equation. And that would be that Vf is equal to velocity in the y direction, but the initial plus acceleration in delta t. And we already established that acceleration is positive 9.8 meters per second squared, and that time is 3.75, and we have the initial velocity. So it's a simple plug-in, and we get 19.1 plus 9.8. And you'll find that the final velocity is equal to 56 meters per second. Now, we're not done. We only have the final velocities in the x and y components. If you remember back from the original problem, we were given the initial velocity at an angle. So therefore, we should also assume that we should give the final velocity at also an angle, which would be 40 degrees. Therefore, we can use Pythagorean theorem to calculate what is our final velocity. So let me draw a triangle. The final velocity will not have an angle of 40 degrees, but it will have some angle. And we know that since the x component and the y component are independent of each other, we could just simply write those by themselves. And we calculate this vector right here, which is the final velocity. And that final velocity is equal to the square root of the y component plus the x component. And that is equal to 58.1 meters per second. So to end this lesson, I just want to emphasize that every single time we get a vector that's in both the x and y component and combined, we have to separate them to both the x and y component before actually working out any of the problems involving kinematic equations, because the kinematic equations only work in one variable or the other, never both. Thank you.